What up, guys? It's Andrew here, and today we are back with another USACO walkthrough here. Today we'll be doing the problem even more odd photos, and this is the second problem of the USACO 2021 January contest in the bronze division. So I've uploaded Uttered But Not Heard and Just Stalling. So this is going to be the final piece to the puzzle here of this USACO bronze contest here. And actually, this is going to be the last USACO Bronze video I will be uploading, unless you guys want me to do a specific USACO Bronze problem. And therefore, I will continue to do USACO Bronze problems on request, but in terms of regular uploading, I will be starting to do USACO Silver content. So let's get into it. Alright, let's start reading here. So, Farmer John is yet again trying to take a photograph of the N cows and is between 2 and 1,000. Not that bad. Each cow has integer breed ID number in the range of 1 to 100. Farmer John has a very peculiar idea in his mind for a photo. He wants to partition all the cows into disjoint groups. In other words, place each cow into exactly one group. Okay. So basically, we have a line of cows, and he wants to group them together somehow, and then line up the groups so that the sum of the breed IDs of the cows in the first group is even, the sum of the IDs in the second group is odd, and so on, alternating between even and odd. What is the maximum possible number of groups Farmer John can join? Okay. So I think that the key word here is maximum and alternating. So in this case, Farmer John, let's get our white space here. He's going to want basically a row when we start with even and odd. So we start with even and get odd. So these are going to be the groups here, and it's going to be basically a lineup, and each of these is basically a group of cows. And in this case, since it says maximum, we got to be thinking about it beforehand. So likely a lot of these groups are going to be just single cows by themselves because this is maximum, not minimum. If it was minimum, we would probably be stacking cows to like the max. We would be stacking like as many cows as we could into like one group, and then we would continue. But in this case, it's maximum, so we have to be thinking about that these groups are going to be rather small, and some of them are not going to be even groups. They're just going to be like one cow, and we can just count them as groups. Okay. So what is the maximum? Yeah, I already read that. So let's take a look at the input format here. So the first line of input contains n. Okay. And the next line contains n space separated integers, giving us the breed IDs of the n cows. So, okay, so that makes sense. So we have 7 cows, and these are the breed IDs. Okay, not too bad. And the output format. So the maximum possible number of groups in Farmer John's photo, it can be shown that at least one feasible grouping exists. Okay. Okay, let's take a look at this sample case here. So we have 7 cows, and their IDs are 1, 3, 5, 7, 9, 11, and 13. And our sample output is going to, in this case, be 3. So in this example, one way to form the maximum number of 3 groups is follows. Place 1 and 3 in the first group, 5 and 7 and 9 in the second group, and 11 and 13 in the third group. Okay, that makes sense. Okay, let's take a look at this other example. So we have 7 cows again, and in this case, one way to form the maximum numbers of 5 groups is follows. Place 2 in the first group, 11. So in this case, we indeed can place only 1 cow in each group. So 11 in the second group, 13 and 1 in the third group, 15 in the fourth group, and 17 and 3 in the fifth group. Okay. So it appears to me that the order of the numbers does not matter. So in this case, we don't actually have to care about like the actual numbers. We just have to care about the number of evens and the number of odds, because in this case, these numbers are completely out of order. We're just judging them solely on whether they're even or odd or not. So now that we got like the general idea of this problem, we can start thinking about how we're going to put this into code form. Alright, so in order to start thinking about how we're going to convert this to a program and the basic thought process behind it, I've created a small slideshow that's going to basically just help us speak how we're going to solve this problem and basically help you guys better understand by thinking behind this problem as well. So, of course, before we do any of this, we need to basically read in the data, read in the cow IDs, and basically count how many odds and evens there are. So once we do that, we need to consider some special cases right off the bat. So based on just simple math, we know that when we add two evens together, we cannot form any odds. So in this case, if all our cow IDs that we read in are even, that means that we can only form all of them into one even group because, again, based on math, we cannot form any odds with evens or even numbers. And second, if all the cow IDs that we get are odd, then we can use this complicated algorithm method called count that can count the number of possible groupings that can be formed with odd IDs. So odd numbers are going to be the game changer here, and we're going to use them to basically count how many maximum groups we have. Because again, if we go back to the problem, we're looking for the maximum possible number of groups in Farmer John's photo. Okay, so once we consider those two special cases, we can consider some general cases when we read in our data. So if we look at the example, the sample cases here, we can see that this one is all odd numbers, and this one has one even number, so we can consider it as even and odd numbers. So in this case, since we want maximum groups, again, we are going to take, cows individually and set them as groups. Basically, each group is just one cow, because in order to maximize the amount of groups, we have to basically just use the cows themselves, and if they're even, if they're odd, that's based on their own cow ID. So we're trying to maximize the amount of groups we have, so we're going to take individual cows first. And so basically we take one even ID cow and one odd ID cow alternatively until either we run out of even ID cows or odd ID cows. So at this moment, if the last group is even, then we give one odd call to the count method. So again, this count method is going to count the amount of possible groups from odds, and else directly call the count method with remaining number of odd IDs. So if the last group is even, that means the next one we need is going to be odd. So that's going to we're going to give one odd, because again, this method is going to assume that we start with an even group first. So we just finished even, now we need an odd for this method. So once we run out of even IDs, we need to give one odd ID first, because this method we can only code this method to basically be aligned with one condition here. All right, so let's take a look at the method here, how we're going to implement it. So we're going to have, oops, oh my god. Okay, so sorry about that. So we're going to have another more special cases to consider here. So if the number of odds that we get, the number of odds that we implement into this method is less than 5, that means we're going to have to consider some special cases here. So if the number of odds is either 2 or 4, then we can only form one group. So if we have 2 odds, that the only group that we can form here is just one even, because in this case, even if we're on an odd one, once we form one odd, we can't form an even with one odds. That just doesn't make sense. So in this case, I can only form one even group or one odd group. So that's only one group. So if we have 4 odds, that's also one group, even though it might be strange because there's 4 odds. We can use a lot of them in there. So in this case, it's only going to be one group, because if we say we start with even, that means the first 2 we're going to have to form an odd. So the first one we're going to have to use it as an odd. So we use this. Let me get the pointer out here. So we use this odd as itself, an own odd, and then we take another set of odds, and that's going to form an even one. In this case, once we do that, we don't have enough odds to form another even, and so on. So again, we can, for 2 and 4, they can only form one group, because we simply do not have enough odds to form enough viable groups with in odd and even pattern. Even and odd pattern. So if the number of odds is 3, then we can only form 2 groups. So this little squiggly here means that they're different groups. So in this case, this is going to be an even group, and this is going to be an odd group. So 3 works fine, but it's still a special case. And if the number of odds is 1, well, we can't really form anything with that, because again, it can only be an odd group, and we can't form evens with that. So of course, we also have some general cases here where the number of odds that we are left over is greater than or equal to 5, and that's shown in this example here. And basically, that in this case, we say we take so 2 odds form 1 even, so that's just the general pattern that strategy that we're going to use to basically process these odds here. So 2 odds form 1 even, and 1 odd form 1 odd. So we do this pattern until we reach where we have a number of odds is less than 5, in this case where we consider our special cases. At this moment, we check the next group to be added, and in 2 different cases. In this case, we have our special cases here. So in this case, we have the number of odds as modeled by 1, 2, 3, and 4. And here here is basically where we're trying to basically get the next group, and this is going to be the group that we last did. So if we say we've done an even group, or next is an even group, that means that we have to form it even with our remaining amount of odds here. So we cannot form an even group with 1 odd, so therefore it's impossible here, so it's marked with an X. And here, if we have 2 odds, that means odd plus odd is even, so we can form 1 even group. Here we have 3 odds. Here we have 2 of them can form 1 even group, and then the remaining odd can form its own group, which is just an odd group. So it's going to be two groups that we can form from 3 odds if the next one we have is an even group. So basically, what I mean by this is that the first one here is an even group, the first one here is an even group as well. And again, for 4, we've talked about this in the last slide. It can only form 1 group because we don't have enough odds. In this case, when we're trying to use an even group first, all of them must be combined to form 1 even group because, again, if we form 1 even group here, we have this odd group here, and we don't have enough odds to form the next even group. So, if we have 1 odd and the next one is an odd group, then that's really simple. We can just use that 1 odd cow to form its own group, so that's 1 group there. For 2, we cannot form an odd group with 2 odds because we have to use all of them, and 2 odds form an even, so that's impossible there. So it's marked with an X. And again, but for 3 odds, if the next one is an odd group, we have an odd group, and then we have another even group. So that's 2 groups right there. And finally, if we're starting with odd for 4 odds, that means that we have 1 odd by itself, then an even group, then another odd by itself. That's what we're fine. So that's 3 odds right there. So now that we have the general strategy of how we're going to basically solve this problem, and we can start thinking about how we're going to program this and implementing this into a code form. Alright, so I've opened up my IDE IntelliJ here, and I've created just a new file into the project for the 2021 Jan's contest, Jan Bronze contest. So as you can see here, USACO uses standard input and output now, so I've just created a nice fine and dandy scanner here, and I've also just read an N and the array of cow IDs as an array. So again, we don't actually have to care about the numerical values of these IDs, so we just have to check whether they're odd or even or not. So let's just do that right now and count and put them into a variable that's going to store how many even and odds there are. So we're just going to count them up right here. So let's first create a variable that's going to be our return value, or the answer that we're going to basically just print at the end of this code. And let's create a variable that's going to store evens, a variable that's going to store odds, and let's just read them in right here. So again, you guys should know this by now if you're deep into this USACO scene. But if you want to check even numbers, then you just check with those by 2. So evens plus, and then else, that means it's odd. So let's do that. Okay. Alright, so that's looking good. So now that we've read in the evens and odds and store them into variables, we can start going back to our plan execution here. So let's go back to the slides real quick. So the first thing that we're going to do is check special cases. So check if they're all even or or all odd. Sorry. Okay. Let's say if odds equal 0. So in this case, if there's no odds, that means that it's all even. So we just return 1 again, going back to those slides if you need a reference. And else if evens equals 0. Let's just comment this out for now, but we're going to say ret is equal to count groups. And we just count. We just make so. Again, this is going to be the method that we're going to make later. That's going to basically count the number of possible groups, given that we have odds. only odds left. So this is just the number of odds, by the way. And so else. So here is where, going back to those slides again, we're just given the general case where there's both evens and odds. So again, we're just going to continuously alternate between reading in evens and reading in odds. So let's just do that here. So in order to alternate, we just need to create a Boolean flag that's going to allow us to alternate between reading in evens and reading in odds. So we can say that this is, let's just call it flag, I guess. And again, we start with the even group here. So here we just get the even and odds alternatively. So while evens is not equal to 0 and odds is not equal to 0. Okay, that's fine. Okay, so if flag, that means if flag is true, that means we're going to read an even. So evens minus minus and ret plus plus. Okay, and then here, sorry, okay. So here, this means else if the flag is false, that means we're going to read an odd. So again, this alternative pattern. So ret plus, oops, ret plus plus. And then flag, we're going to have to reverse it every time because it's an alternative pattern. And there we go. Alright, cool. So that's where we read in, or we just, we use all the possible odds and evens, and we basically add them to ret. So right now, we have our variable ret, and it stored all the possible groups that we have that uses that maximizes the odd and even cows by themselves. So now we actually have to check the remaining amount of cows. So let's do that here. Okay, so here we check the remaining cow IDs. Alright, so again, once we get to the remaining ones, we also have to consider special cases. Okay, so if odds is equal to 0, that means that the remaining is all going to be even. So again, we only have one more group. So all even, one more even group. Oops. Ret plus plus. Alright, sorry. So ret plus plus here. And okay, so from there, we're going to add an else statement right here. Okay, so else. Let's see here. Else. Okay, if flag, that means we're going to continue. So again, if we go back to our slides here, so let's see. Okay, so okay, right here. So we take one even ID and one odd ID alternatively until either even or odd IDs run out. So at this moment, if the last group is even, then we give one odd call. Then we give one out ID and then call the count method. So that's exactly what we're going to do right here. So we're going to say odds minus minus and then ret plus plus. And then from there, we're just going to say, let's just comment this out for now, but we have to write the method first. So say count odds. And then finally, for our just general output for this this problem that's going to finish the problem, we're just going to say system out the print line ret. There we go. Okay. And that should do it. Now all we need to do is write that method here. So let's just call it count. And again, we're just going to be given a number of odds. So first we let's just create this variable that's going to hold the number of groups, and this is what we're going to end up returning. And so again, we have to consider the special cases. Go back to the slides if you need reference. But basically, if odds equals to 2 or odds equals to 4, that means the groups is going to be 1. And else if odds equals to 3, again, go back to those slides you need reference. Groups are going to be equal to 2. Oops, this is the wrong thing. Alright, else. So again, else, that means that it's greater than or equal to 4, so we can just start our regular processing strategy, which is basically just for general cases, 2 odds for 1 even, 1 odd for 1 out. So we're just going to basically do this. I'll show it to you guys real quick. So we're basically going to process each set of 2 odds for an even and a 1 odd for a regular odd. So let's deduct is going to be the amount of odds we're deducting to create an even or an odd. So again, if it's even, we deduct is going to be equal to 2. If it's odd, deduct is going to be equal to 1. So right now we're starting with an even one here. So again, while temp is greater than equal to 5 or just greater than 4, temp minus equal to deduct, and groups plus plus. Oops, oh my god. Okay, and from there we have to check if deduct is equal to 2. That means we have to switch back to odds. Okay, and else. So normally it's going to be deduct is equal to 2. So deduct is equal to 2 right now because we're starting with evens. But otherwise, deduct is going to equal to 2 when we're going back to those odds. So again, it's another one of those alternatively changing patterns. All right, that's good. So over here, so here we're going to after we've processed all of the odds and there's 4 or less left. That means we have to start considering the special cases again. So deduct equals to if deduct equals to 2, and okay. So if temp, so we're gonna do something really similar here. Our temp is equal to 4. Groups plus plus, and else if temp is equal to 3. Groups plus equal to 2. So this is very similar to what we did up top, but in this case we're considering those final leftover odds. So again, it's the same kind of strategy that we're using here. Okay, so if it's 3, then we add 2, and then from here we go else if deduct equals 1. So if deduct equals to 2, that means we're on an even one, and if deduct equals to 1, so again we're just here referring to that table here. So once we're left with this number of these different numbers of odds, and if a deduct is basically going to allow us to determine whether next is even group or next is odd group. So if deduct equals to 2, that means if it's any of these, then we consider these cases, and deduct equals to 1, then we consider these cases. So right now we're just modeling those right here. So deduct equals to 1, that means that if it's 1, we have 1. If it's 2, we don't consider 2 at all. If it's 3, it's basically 2 groups. If it's 4, it's 3 groups. So let's just write that in right here. Yeah, okay. That means if temp equals to 1, groups plus equal to 1, and else if temp equals to 3, groups plus equals to 2, else if temp not tempo, well, okay, temp equal to 4, and groups plus equals to 3. Finally, go down here. What is our true goal? Well, that's just, let's see, which one does it match? Okay, that's just to return groups. And there's the method. Oops. Oh, God, okay. There we go. Let's see what's wrong here. Flag is not always true. It's not true. We change it here. And yeah, there we go. So, now that we've created our method, we can uncomment the method calls right here. Oops, did we misspell count? Oh, we just call it count. Let's just call it count. Okay, and right here. Alright, so here we can just run a sample test, I guess. Let's see if it just compiles correctly. Alright, it's taking quite a while. Okay, so now we can go back to the problem and let's take the sample input and copy it through. Enter, and we get 3. So I believe that is the correct answer. Yep, there we go. Alright, great. Let's try logging in here. Okay. And let's try submitting it to the online grader here. So choose the file here. So let's go green bronze. Sorry for odds. And let's go. Alright, grading in progress. Nice. Great. Compiled fine. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, 11. Wow, there's actually 11 cases for this one. Okay. So yeah, that was even more odd photos. It's the second problem in the bronze division of the 2021 January contest. And there you go, guys. That was the walkthrough. I sincerely hope you subscribe and like if you enjoyed the video. Andrew out.